Okay, so if we look at how the electricity is transmitted from the power plant all the way to your house, right? So you need to see the steps that it undergoes. First, at the power plant, it will generate electricity. So how it generates electricity is by turning the turbine, because when the turbine turns, it will rotate the coil in between two large magnets, so that causes a cutting of flux, so you'll get an alternating voltage. So how you turn the turbines, it depends lah. Some people will use fuel like diesel, or use coal, or use natural gas, and then they will burn it. So there are two ways. After you burn it, you can straight away use the exhaust gases to turn the turbine, but it is very inefficient because all the heat that you generated is just wasted because you're just using the exhaust gases. The more efficient way of generating electricity is that you use the exhaust gases to preheat the water, but the heat that you generate is the actual heat that you use to boil the water. So when the water turns to steam, steam is the one that turns the turbine. And the exhaust gases are not wasted because it's used to channel into the water to preheat the water first. But this type of system, when it boils the water, it will take a longer startup time because you have to boil the water first. So the typical starting time is a few hours, all right, 4 hours, then only it runs. So this type of power station that runs on steam, they must be operating continuously, because for you to stop and then start again, it takes too long. The one that uses the exhaust gases to turn the turbine, those are very fast. That one you can operate in 1-2 hours. So for those power stations that need to operate very quickly, you use exhaust gases, but it's very wasteful. So you only use it like there is no choice when the sudden spike in demand and you cannot meet it, then you quickly turn this kind of power stations on. But the more so-called greener way of generating electricity is like hydroelectric, like damming up the water, let it fall through a great height, turning a turbine. Or you can use nuclear power stations where they will use nuclear fission to generate the heat, and the heat is used to boil the water. Then once it turns to steam, then it turns the turbine. So all these are so-called greener technologies, but they also have some pollution in other ways, not exhaust gases, but through other ways. But anyway, after generating the electricity, what will happen is they will have to step it up. So there's a large substation here, transformer substation. It could be as big as a building. That's how big the transformer is, because you need to step it up to a very high voltage. Like just now in the example that we use in the question, maybe here the power plant generates at 11 kilowatts, and then after that maybe it steps it up to 275 kilowatts. So why do they want to step it up? Is so that when the voltage is high, the current is low. So I'll show you the calculation later. So power loss in your cables is actually given by P equals to I squared R, remember? So if I can reduce the current in your cables, you will actually reduce the amount of power loss in the cables during transmission. Alright? So anyway, so let me just write down again. So P equals to I squared R. So once this electricity is transmitted over large distances, right, and you will notice that this type of cables that you see are beside your highway, the one you see that's very high up, and you will notice that there are a lot of orange balls that you will see hanging there. So what are they used for, the orange balls, right now? Because these high voltage transmission lines are very dangerous, mainly because of electrocution, in case you actually touch it. But it also has another danger. It generates low frequency EM radiation, because as the current goes back and forth, there's a acceleration and deceleration of electrons, so that actually generates EM radiation of low frequency, which some people have said it can cause leukemia. So that's why they make it as high as possible, so it will not affect those people underneath. So what will happen is, because it's very high, they have to warn the low-flying aircraft in case it collides with it. That's why you have the orange balls here, right? So that's the story. So then it goes on until it reaches, let's say, a housing area. You'll notice that there's a big power substation in every housing area. So what they will do is they will step it down one step first. Example, it steps it down to 11 kilowatts. So the question is, so why you want to step it down to 11 kilowatts? Our house never uses 11 kilowatts right now. So 11 kilowatts is mainly for factories. Why factories use 11 kilowatts? Because their power of the machines are very great. So if you use the formula P equals to VI, if the power is very big, but you're using a very small voltage, 240 volts, then the current will be very, very high. And that means your cables have to be very, very big and thick. So in order to reduce the size of the cable that you use, you must use a smaller current, which is why they use higher voltage. Example, they use 11 kilovolts. But if it is to be used in the house, then it will transfer again. Once you reach the end of the street, there will be a small transformer drum which steps it down to 240 volts for us. So that is so that if you accidentally touch the live wire, there's less danger for us of dying. Okay, so that is the whole story. So let's look at the calculation here. Now, the power generated in your power station, which is this, is equals to the voltage at the generator, so we call it like the EMF, times the current. Now, the current that you generate at the generator, that same current will flow out into your cable. Why? Because they're connected in series into the load and comes back. So current is the one that's the same. So when I write the power loss in the cable, I will write as I squared R, and the current in this equation and the current here is the same, because the current in your cable is the same as the current in your supply. So from this formula, my current is equals to the power generated over the voltage of the supply. So if I were to substitute back inside here, I will get P gen over VI squared over times R. So that means the bigger the voltage I use at the supply, the smaller my power loss. But some students get confused. They tell me that power loss is also given by the formula P equals to VI, right? Correct? Then they said, according to this formula, the higher the voltage, the higher the power loss. But here I said the higher the voltage, the less the power loss. So which is true? Now there's nothing wrong with this formula except that this V and this V they do not represent the same thing. This VI is the voltage at your supply. This V is because we are talking about the power loss in your cable, it must be the voltage in your cable times the current in the cable. So this V is the voltage in the cable, which is true. The higher voltage in the cable, the more the power loss. But here our formula is not referring to the voltage in the cable, it's referring to the voltage in your generator. So the voltage in your generator definitely will not be the same as the voltage across the cable. If you remember Kirchhoff's law in your AS, the voltage of your supply, which is your EMF, equals the sum of PD in the circuit. So it will be this PD plus this PD plus this PD. So the voltage is talking about PD across your wire, which won't be the same as this. Okay, so don't confuse.